When seeking a replacement for a 2-pole 100 amp Murray circuit breaker, specifically the 2-pole 100 model, several avenues can be explored. Firstly, consider contacting electrical suppliers who may have the breaker in stock. Reliable Electrical Experts Incorporated and JT Electric are potential sources. Links to these suppliers are available online. Secondly, it's important to understand the interchangeability of circuit breakers. Murray breakers are no longer manufactured. However, some General Electric, or GE, and Siemens breakers might be interchangeable with Murray breakers. To determine compatibility, consult the Underwriters Laboratories, or ALL, database for specific models that are listed as suitable replacements. This database provides information on which breakers have been tested and approved for use in place of the original Murray breaker. Before replacing any circuit breaker, certain troubleshooting steps are recommended. Firstly, verify that the 2-pole breaker is indeed the correct amperage, which is 100 amps in this case, for the specific application. Using a breaker with a higher or lower amperage rating can create safety hazards. Secondly, carefully check the wiring connections to the breaker to ensure they are secure and properly tightened. Loose connections can cause arcing and overheating, which can damage the breaker and the wiring. Thirdly, thoroughly inspect the breaker itself for any signs of damage or overheating. Look for discoloration, cracks, or melted plastic, which could indicate a faulty breaker. If a direct replacement cannot be found, it's advisable to consult a licensed electrician. An electrician can assess the situation and explore alternative solutions, such as using a different brand of breaker that is compatible or upgrading the entire electrical panel if necessary. It is extremely important to consult with a licensed electrician for all electrical repairs and replacements. Using an incorrect or incompatible circuit breaker can pose a significant safety hazard, potentially leading to electrical fires, equipment damage, or personal injury. When dealing with electrical systems, safety should always be the top priority. If you are searching online, include the voltage in your search. A 2-pole breaker is normally used for 240 volts, so search for a 2-pole 100 amp 240 volts breaker. Also, if you are searching on a supplier's website, try searching for 100 amp breaker without the 2-pole or 2P to see if it comes up. Be careful to note that a 2-pole breaker takes up 2 spaces inside of your electrical panel, since you do not want to get a single-pole breaker by mistake. The most important thing is to find the correct voltage, amperage, and number of poles that the breaker you are replacing has. It is essential to check the UL listing and follow NEC 110.3. When examining the compatibility of circuit breakers, especially when considering replacements for discontinued models like Murray, several factors come into play. Firstly, physical dimensions are crucial. The replacement breaker must fit properly into the existing panel board or load center. This includes the overall size and shape of the breaker, as well as the configuration of the mounting clips or busbar connections. If the physical dimensions are not compatible, the breaker cannot be installed safely or reliably. Secondly, the electrical characteristics of the replacement breaker must match or exceed those of the original breaker. This includes the voltage rating, which must be equal to or greater than the system voltage, and the interrupting rating, which must be sufficient to handle the available fault current at the installation location. The interrupting rating is the maximum amount of current that the breaker can safely interrupt without failing. Thirdly, the UL listing or other recognized certification mark is an important indicator of safety and performance. A UL-listed breaker has been tested and evaluated by Underwriters Laboratories to ensure that it meets applicable safety standards. When replacing a breaker, it is recommended to use a UL-listed breaker that is specifically listed as a replacement for the original breaker or is otherwise approved for use in the panel board. Fourthly, consider the type of breaker. There are different types of circuit breakers, such as thermomagnetic breakers, electronic breakers, and solid-state breakers. Each type has its own advantages and disadvantages in terms of performance, reliability, and cost. When replacing a breaker, it is generally recommended to use the same type of breaker as the original unless there is a specific reason to switch to a different type. Fifthly, compatibility with the panel board is a key factor. The replacement breaker must be compatible with the specific panel board in which it is being installed. This includes the busbar configuration, the mounting hardware, and the overall design of the panel board. Some panel boards are designed to accept only certain types or brands of breakers, while others are more flexible. Consult the panel board manufacturer's instructions or a qualified electrician to determine which breakers are compatible with your panel board. If you are unable to find a direct replacement for the Murray breaker, consider contacting the manufacturer of the panel board. They may be able to recommend a suitable replacement or provide information on alternative solutions. Additionally, there are online forums and communities where electricians and other professionals share their knowledge and experience. These resources can be helpful in finding a replacement breaker or getting advice on how to troubleshoot electrical problems. Remember that electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. An electrician can ensure that the replacement breaker is installed safely and correctly, and that the electrical system is functioning properly. When searching for a replacement breaker, you might come across terms like classified or recognized breakers. These terms refer to the level of testing and evaluation that the breaker has undergone. A classified breaker has been tested by UL to verify that it meets certain performance and safety requirements. A recognized breaker, on the other hand, has been evaluated by UL as a component of a larger system, but it has not been tested as a standalone device. In general, a classified breaker is preferred over a recognized breaker, as it provides a higher level of assurance that the breaker will perform as intended. However, a recognized breaker may be acceptable in certain applications as long as it is used in accordance with the manufacturer's instructions and the applicable electrical codes. When selecting a replacement breaker, it is important to consider the environmental conditions in which the breaker will be operating. For example, if the breaker is located in a damp or corrosive environment, it may be necessary to use a breaker that is specifically designed for those conditions. Similarly, if the breaker is located in an area with high temperatures, it may be necessary to use a breaker with a high temperature rating. The National Electrical Code, or NEC, provides guidance on the selection and installation of circuit breakers. NEC 240 covers overcurrent protection, including the requirements for circuit breakers. This section of the code specifies the types of breakers that are permitted in various applications, as well as the requirements for breaker ratings, interrupting ratings, and other performance characteristics. It is important to comply with the NEC when selecting and installing a replacement breaker. When replacing a breaker, it is also important to consider the impact on the rest of the electrical system. For example, if you are replacing a breaker that protects a critical load, such as a life safety system or a data center, it may be necessary to take additional precautions to ensure that the load is not interrupted during the replacement process. This could involve using a temporary generator or other backup power source. Additionally, it is important to verify that the existing wiring and other components of the electrical system are in good condition and are capable of handling the load that will be placed on them by the new breaker. If the wiring is undersized or damaged, it may be necessary to upgrade it to ensure safe and reliable operation. Remember that replacing a circuit breaker is not always a simple task. It requires careful planning, attention to detail, and a thorough understanding of electrical principles. If you are not comfortable performing the work yourself, it is always best to consult with a qualified electrician. They can assess the situation, recommend the best course of action, and ensure that the work is done safely and correctly. Consider the potential for nuisance tripping. Nuisance tripping occurs when a breaker trips for no apparent reason, or when it trips due to a transient surge or overload that is not actually harmful to the electrical system. Nuisance tripping can be caused by a variety of factors, such as loose connections, faulty wiring, or a sensitive breaker. If you are experiencing nuisance tripping, it may be necessary to replace the breaker with a more robust or less sensitive model. It's important to follow lockout-tagout procedures. Before working on any electrical equipment, it is essential to follow proper lockout/tagout procedures to ensure that the equipment is de-energized and cannot be accidentally energized while you are working on it. This typically involves turning off the breaker that supplies power to the equipment, locking the breaker in the off position, and tagging the breaker to indicate that it is being worked on. Lockout/tagout procedures are designed to protect workers from electrical shock and other hazards. When replacing a circuit breaker, it is important to properly dispose of the old breaker. Circuit breakers contain materials that can be harmful to the environment, so it is important to dispose of them in accordance with local regulations. Many electrical supply stores and recycling centers will accept old circuit breakers for recycling. The main thing to remember is to be safe and to take your time. Electrical work can be dangerous, so it is important to be careful and to follow all safety precautions. If you are not comfortable performing the work yourself, it is always best to consult with a qualified electrician. They can ensure that the work is done safely and correctly and that the electrical system is functioning properly. Always double-check your work. After you have replaced the circuit breaker, it is important to double-check your work to ensure that everything is connected properly and that there are no loose wires or other potential hazards. You should also test the new breaker to make sure that it is functioning properly. One way to test the breaker is to use a circuit tester to verify that power is flowing to the circuit that the breaker protects. Another way to test the breaker is to create a controlled overload in the circuit and see if the breaker trips as expected. The goal is to safely restore power. Once you have verified that the new breaker is functioning properly, you can safely restore power to the circuit that it protects. Be sure to turn on the breaker slowly and carefully, and to monitor the circuit for any signs of problems. If you notice any problems, such as flickering lights or sparking wires, turn off the breaker immediately and consult with a qualified electrician. Remember that electrical systems are complex and potentially dangerous, so it is always best to err on the side of caution. If you have any doubts or concerns about your ability to safely replace a circuit breaker, it is always best to call a qualified electrician. When determining the correct replacement breaker, it's helpful to have the full model number of the breaker being replaced. Also note the date code if available. The full model number and date code can provide more specific information about the breaker's characteristics and compatibility. This may be located on the side. These are often printed very small, so you may need to get a flashlight to read them. A magnifying glass may even be necessary. Remember that simply because it looks like it fits, does not make it suitable for use. Check the specifications carefully. When you reinstall the wiring, make sure that the wire is seated properly inside of the breaker. When you tighten the screw, the wire should not be able to come loose, and the wire should not be mashed or damaged. If the wire is damaged, then cut off the damaged section and re-strip the wire so that you have a fresh surface to work with. You should leave the wire long enough that you can work with it, but short enough so that it does not come in contact with anything that it shouldn't. The wire should also be neat inside of the panel and not running across other breakers. Always consult the most recent version of the NEC before beginning work.